plots. Let us know more about the natural indicators around us. The special types of substances which change their color when come in contact with acidic or basic substances are called indicators. These are used to test whether a substance is acidic or basic. The following are the natural indicators around us. They are turmeric, China rose petals, phenolphthalein solution, methyl orange, litmus solution. Click each tab to know more. Let us do another activity on olfactory indicators. Take a plastic bag. Take some finely chopped onions. Place the finely chopped onions and cloth inside the plastic bag. Tie up the bag tightly. Keep it inside a fridge for an entire night. Now, the cloth strip can be used to test for acidic and basic nature. Take 2 strips of the cloth and check their odor. Put them on a clean surface. Pour few drops of dilute hydrochloric acid solution on one strip and a few drops of dilute sodium hydroxide solution. Wash both cloth strips with water. Again check their odor. Note the observations. Onions do not smell strongly in basic solutions. The red onion also changes from pale red in an acidic solution to green in basic solutions. Take dilute vanilla essence and clove oil. Check their odor. Now take some dilute hydrochloric acid solution in one test tube and dilute sodium hydroxide solution in another test tube. Add few drops of dilute vanilla essence in both test tubes and shake well. Check the odor of the solutions and note down your observations. Similarly, add clove oil in both the test tubes and shake well. Again, check the odor of the solutions and note down your observations. Reaction between acids and bases with metals. Pickles and other sour substances are acidic in nature. When they are stored in metal container made up of brass or copper, they get spoiled. This is due to the reaction between acids and metals. Let us perform lab activity to learn about this type of reaction in detail. The aim of this activity is to study the reaction of acids and bases with metals. Click each tab to learn more. Here, let us perform an activity example of reaction. Place the retard stand on a table. Adjust and fix the test tube on horizontal rod. Take about 10 ml of sodium hydroxide solution, NaOH, in a test tube. Now, add a few pieces of zinc granules to it. Warm the contents of the test tube. Observe the surface of zinc granules. Insert one end of delivery tube to the test tube through its lid and also insert another end in glass tub. Fill the glass tub with soap water. Now pass the gas evolved through the soap water. At this time, bring a lighted candle near a gas-filled bubble. Observe the reactions. Make a note. Be careful while handling the acid. A gas evolves from the boiling tube and passes all along the delivery tube. The gas puts off the burning matchstick at the open end of the delivery tube. The evolved gas is hydrogen and salt is sodium zincate. Sodium zincate and hydrogen gas are formed by the zinc metal when it reacts with sodium hydroxide solution. However, such reactions are not possible with all metals. After learning about chemical reactions in detail, let us now learn the reaction of carbonates and metal hydrogen carbonates with acids. Take 2 test tubes. Take about 0.5 grams of sodium carbonate Na2CO3 in one of the test tubes. Again, take about 0.5 grams of sodium bicarbonate NaHCO3 in another test tube. Now, add about 2 ml of dilute hydrochloric acid HCl in both test tubes. Observe the gas bubbles in both test tubes. Pass the evolved gas through the lime water, calcium hydroxide solution by using the deliverable tube. Observe the chemical reactions. The reaction of metal carbonates and hydrogen carbonates with acids gives a corresponding salt, carbon dioxide and water. The generalized forms of these chemical reactions are shown on screen. Let us perform an activity to learn about the neutralization reaction. Take a test tube. Place 2 ml of dilute NaOH solution in test tube. Add a drop of phenolphthalein solution to sodium hydroxide solution. Observe the changes. Now add diluted HCl solution to the above solution drop by drop. Observe the changes. Once again, add few drops of sodium hydroxide to the mixture solution. In this activity, we observe that there is no change in the color of hydrochloric acid while adding phenolphthalein solution. The color of the solution in the test tube becomes pink by adding a drop of hydrochloric acid. The pink color of the mixture solution becomes colorless by adding a few drops of sodium hydroxide solution. In this activity, the reaction occurring between acid and base is shown on screen. The effect of base is nullified by an acid. The reaction of an acid with a base produces salt and water, known as neutralization reaction. Let us learn the reaction of metal oxides with acids. Let us learn the reaction of metal oxides with acids. Click each tab to learn more. Take a test tube. Place a small amount of copper oxide in it. Now add diluted hydrochloric acid. Observe the changes. The copper oxide dissolves and the color of the solution becomes blue-green. The reaction of copper oxide with hydrochloric acid produces copper chloride and water. Finally, we can conclude that this reaction is similar to the reaction of a base with acid. Hence, we learn that metallic oxides are basic in nature, like the metal hydroxides. Now, let us learn the reaction of a non-metal oxide with a base. Reaction of non-metal oxide with a base. As far, we have learnt that the calcium hydroxide is a base and reacts with carbon dioxide to produce a salt and water. This reaction is similar to the reaction between a base and an acid. So, we can say that carbon dioxide, which is non-metal oxide, is acidic in nature.